Quadratic functions in all three forms and when we use them. If we look at the graph you see on the screen, it models the height of a rocket after its launch, where the height's in meters and the time is in seconds. So what I really need to think about is, what do I need to solve various things? If I want to know the height of the platform from which the rocket was launched, well, the rocket's launched when time is 0. So what does that tell me I need? It means I need the y-intercept. And if I had the equation, I would want the standard form equation because that's the only one where I can read that off easily. And if I look at the graph, I'm increasing by 2's for my height, and it looks like it is launched from a height of approximately 15 meters. If I want the maximum height reached by the rocket, well, that occurs right here. That's my vertex. Again, if I had an equation, I'd want vertex form, and it looks like the maximum height of the rocket is approximately, or it looks like it's exactly 20 meters based on this graph. How many seconds after the launch was this height reached? This height referring back to the maximum height. So of course that has to be referring to the vertex location for time. So time is 1 second at the vertex. When will the bottle rocket hit, or when will the rocket hit the ground? Well, that's an interesting question. When will it hit the ground? If I think about it, it hits the ground when its height is 0. Well, that happens after 3 seconds, which is a 0, which comes from factored form or possibly using the quadratic equation. Oops, I don't want to have that there. When will the height of the rocket be increasing or decreasing? Well, if I look, it's increasing until it reaches the vertex because the y values are getting bigger. It decreases until it reaches the 0. So the increasing interval happens between 0 and 1, and we don't include 1 because at 1, it's hit its maximum. It's not increasing anymore at that point. Right after that, it starts to decrease. So it's decreasing from 1 to 3. And notice we stopped at 3, and of course, I've got some bad mathematical form here because this should be time. And that should also be time because we always talk about intervals of increase with respect to our independent variable. If we had the equation, we would be looking for the x-coordinate of the vertex, and that would be our breaker indicating when it was increasing or decreasing. Last thing, if I talk about the hang time of the rocket. Hang time is a new word. It's referring to how long the rocket's in the air. Well, if I look, I'm looking for my zeros. Had I started from 1 and gone up and come down at 3, I would have had a hang time of 2 seconds. But since I started right at 0, my hang time is 3 seconds. And before you come to class, have a look at exercise 5 on page 10, numbers 1 to 3.